How's it going, everybody? In this video, we're going to take a look at BGP's second attribute for path selection, known as local preference. And local preference is kind of a unique attribute in the fact that it is configured on one router, but the information is propagated to all the routers in the local autonomous system. So the cool thing about it is you can set the local preference on, say, router 3 to prefer all routes out router 3 to leave the network. And when you set it on router 3, any router that has any router that's running BGP will receive that update and change all of its routes to point to router 3. So the cool thing about it is when you have an autonomous system number, whether it's 1, 2, or 5,000 routers, you set local preference on a particular you set default local preference, which default local preference is going to mean all routes, or that particular router going out towards a particular neighbor. So router 3 towards router 6. You can set up so that all routes go out router 3 towards router 6. Or you can get more specific and you can say any routes that are destined towards, that originated in, say, AS789 are going to be, you want to prefer them out router 3. So, or you could do a particular subnet. So pretty much what we did inside of the weight configuration, you can do with inside a local preference. And that gives you a lot of flexibility, a lot of granularity in your design. So if you want to go left over right, you can do so if you want to. That's the one thing that makes BGP very unique, and in most cases the most complicated protocol for most engineers that I've worked with to understand, because there's so many little things that you can change and tweak and things like that. So right now on router 5, I believe it is, we configured BGP wait. So do show run pipe section BGP. Okay, so and we should have wait still applied on the neighbor statement, and we do towards 135, right? So we're setting that up, and if we look at do show run pipe section route dash map, I want to see where we're at with that particular link. And the reason for that, and we're going to be looking at R14, so do show IP prefix list, and R14 is for R14's loopback is what we're permitting on that. So that's where we're coming from with that one. Now what we want to do is on router 8, since we're not, and actually we take a step back here, since we're not redistributing EIGRP into BGP, we're not going to see any of the internal routes. However, on router 1, we are redistributing OSPF into BGP, so that's why we're going to see on routers, say router 14, we will see do show IP route. We'll see the router 1's loopback in there is configured, right? So that's the idea of where that comes from. So that's why you see a bunch of BGP routes in the routing table, because they're being learned via BGP. Now that doesn't necessarily mean that we're going to have reachability, though, because remember, routing is bidirectional. So you might have a route to them, but they might not have a route back to you, and that can cause problems. So if you have a situation where you don't know how to get to somewhere, or you do know how to get somewhere but they don't know how to get back to you, you could cause issues in the environment and potentially black hole traffic. So what we're going to do is on router 8, I'm going to redistribute EIGRP into BGP just for this exam, or just for this section. I'm going to pull that out because when we get into services, we start talking about NAT. We're going to be natting things over to that particular natting things from, say, 67 to different addresses. So the 67 subnet over here, and then the 36 subnet over here are going to be natted uniquely to different things, to different IP addresses internally. The reason for that is when you're dealing with the internet routing, and you're trying to get trying to allow an external a lookup to reach an internal resource, that's where NAT comes into play. Now normally you're going to have anything that's going to be internet facing inside of a DMZ behind a firewall, and you're only going to allow certain types of traffic to talk to that box, and that box is going to be segregated in such a way that, let's say for instance it's a database driven web server. meaning like you log in and you type in, I want to look up, say, you go to eBay and you type in, you want to know how much an IBM server is. So you type in IBM rack mount server. So that's a database-driven website. You go there. The web front end is, probably, I'm going to guess like PHP or, ASP.NET or something like that. I'm not a web programmer, so if I'm wrong, don't shoot me. But it probably calls back to a SQL database on the back end or an Oracle database, and that database is there's going to be a lot of stuff on the database back end for the application on the front end. So that's generally how that's going to take effect. So you go there, eBay's got web-facing web-facing web servers, and these web servers are going to be database-driven. So we'll take more of a deeper look at that when we get into it, but I want to make sure everybody understands where I'm coming from. So right now we have BGP running. So we have the peering to 9 and we have a peering to 7. So we're going to type in router BGP 789. We're going to type in redistribute EIGRP 789. Hit enter. Okay, so it's going to bring those routes in. Now if we go to router 1, we type in show IP route. It might take a moment for this to propagate, but eventually we're going to see routes coming from, and we have 8, and it just came in 7 seconds ago. So that means we should be able to trace route to 10.255.8.8, and we can get there. That's a great sign, because 8 knows about us, we know about 8. It's bidirectionally known, we're good to go. So now what we're going to do, since we have that piece in there, we can start going a little farther with our setup. So the way we're going to work on this is we are going to take a look at this from really, really wide to getting very, very small. So we can show you the level of granularity that you can come into play with. Now what I mean by that is if we were to go to I want to go to router 3 and I want to use local preference to choose a particular, to choose all routes go out router 3 for everything. So on router 1 we did the trace route and went out router 3 anyway. So that might just be the fact that where it was learned in. I'm not exactly sure. Looks like a lot of stuff is coming in. Oh, okay, it's load balancing across a lot of stuff. So what we're going to do is, are we getting a default route? Okay, we are getting a default route. So let's trace route to 8.8.8.8. Okay, so this time we went out router 4 to router 5. So that's how we got that route, and that's how it knew how to get there, was through router 4. So it looks like we're getting equal shares 3 to 5, and so on and so forth. So what we want to do on router 3 is we're going to go to global config, type in router BGP 12345, and from here what we're going to do is we're going to type in address family IPv4. We're going to type in BGP question mark, and if you look, BGP default. Or is it BGP default, or is it just default? Default. If you look, let's see here. May not be here. Might be just underneath the default. Let's see here. Default BGP. I don't see it. Let me find it here. It's in. What I'm trying to do is, when you're dealing with this, there's a thing called default local preference, and BGP default local preference. There it is. So right there, local preference. The idea with this is, by default, local preference is 100. So if you wanted to change that to make, let's say, and higher is better. So we'll say 10,000 or some arbitrarily high number. Okay, so we're going to type in do clear IPBGP star soft. Now let's go to router 5. We're going to do a do show IPBGP. Now if you look, any routes that come from 4 or 2 are going to have a local preference of 100. But anything that comes from router 3, and it's only router 3, the 36 network. And if you're seeing this, they all have a local preference of 100,000, which means that's going to be the way we go. we all go out router 3. For every route that's we're being learned in, we're going to go out router 3. So this means that no matter what route we take, you do a trace route to Google, we should leave out 36. Well, in that case, we're not because it's a shorter match. But if we did a trace route to 10.255.14.14, we're going to go out 36. That's the direction we should be going. The same thing with if we went out, let's see, is that 10.10? Should go out 36. Any BGP learned route should be going out router 3 towards 6 because the local preference is set as such. Now, let me get a little more granular here, and what we're going to do is we're going to make sure the traffic, we're going to keep that itself, but what we're going to do is we're not going to tweak anything on this router. We're going to keep it the way it is. What we're going to do is now we're going to go to router 5, and we're going to say anything that's coming from router for these two routes, anything coming from that was originated in 10 or 14. So let me just double check that those are set up the way that they are. BGP 10.10 and 14.14. So on router 5. I'm going to exit out of here, and I'm going to type in IP AS path access list is going to be 100, and we're going to say we're going to permit, and we're going to say the regular expression is going to be underscore 10.10 $, as well as underscore 14.14 $, which means anything that was originated in 10 or 14, we want to match that particular AS number. Hit enter. We're going to type in route-map, and we're going to say local pref, and we're going to say match AS path 100, and that's all we have to type there. We're going to set the local pref to be 101,000, which means 101,000. So anything the default local preference right now is 100,000. So if you make it any value higher than that, so 100,001, that would also apply. Now what we're going to do is we're going to type in, but this is only for routes coming from 10.10 and 14.14. So router BGP 12345, address family IPv4, neighbor of 56.0.0.1. We're going to type in route-map of local pref, but we're going to set this inbound because we're affecting outbound traffic. So you're affecting it. Anything that's coming into the network, you want to affect how it's going out. So, or how you're going to reach it, I should say. Yeah, you're going to do that. We're going to do let's take a look at 3 real quick. Type a do show IP BGP, and as you can see, nothing's changed here though. I don't know if you noticed that or not. So what we're going to do is we're going to change a lot of these routes that are going out 56. I don't see anything in 56 at all, honestly. So we're going to go back to 5, and we're going to type in do clear IP BGP star soft. We'll go back to router 3 and hit the up arrow. And you don't see it being affected here. For some reason he doesn't. Does he see it? Could be the fact that he's not learning it from him. 1.1. Let me type in do show IP BGP summary. I'm learning 20 routes from 5. But I don't see anything coming in from there. Oh yeah, I do right there. 135. I don't see anything coming in from 56. So we did a triggered update. Now let's go to 1, and we're going to type in show IP BGP, and let's see here. Is 2 seeing it show IP BGP? The way that I did that's kind of unique, so it might not have taken the way that I'm looking for it to take. The idea here is to have anything coming from 10.10, and see these routes right here should be coming in with a local preference. So let's do a clear IP BGP star soft. Yeah. Okay, so we have some obvious Okay, so wait a minute, let's see here. Sub's coming from 336, which is fine. Let's see, so we're getting stuff in. You know what it might be? Let's see here. Let's go to global config and do a show or router BGP 12345 BGP AS notation dot. That might be has something to do with it. So do show IP BGP. There it goes. So let's do a. Now it's seeing it correctly with the right AS number. Let's do a clear. Do clear IP BGP star soft. Yeah, it's not. Do I have my syntax correct? Let's go to 5 and do show run. I'm thinking I might have my syntax incorrect. Looking for an AS path ACL. Let's see here. Is it in here? AS path. Yeah, well, it's in there. I got the right syntax. That's weird. It's not. I don't know why it would be coming in, or maybe I have to do it. Let's go to 1 and let's see. Well, you've seen it work with weight, and I'm not sure exactly why it's not working here. But the idea here is on 5 with the AS path ACL. What that would do is it would see where is the traffic being originated from, and it would look at the AS path number. So do show IP BGP. So do show IP BGP. You would see where it's coming from, which is 14. This is where it's originated. So this route should go out towards be going out towards the 56 network on 5. But for whatever reason, it's being oh, it's because of weight has some. That's why. That's why. So on 5, let's do a because remember it's the attribute. So weight's going to be chosen over anything else. But for 10, it should be choosing that. It should be choosing. It's actually choosing to go router 3. So why is it not? Interesting. Anyway, I'm not sure why that's not working the correct way. So the idea, like I said, the idea here is to get traffic to go out a certain way based off of the AS path list, and I'm not sure why that's not pulling it in. Let me do a, let's go to router 5 and do a do clear IP BGP star. Let's do a hard reset. Sometimes a triggered update. And I haven't played with this stuff in a couple days, so it might just be stuck. So let's go to router, and the weight would be locally originated. So let's go to router 1 and do a show IP BGP. And as you can tell, yeah, it doesn't make a difference. Let's see here. He's not even learning anything from 5. That's the problem. Let's do a show IP BGP summary. Who am I learning? Oh, that's why, because I haven't learned any routes from him. So why haven't I learned any routes? That's weird. Let's see. I have a peering up, but I haven't advertised routes to 1. Why is that? Let's do a do show run pipe section BGP. That's probably why I have the next top out. Let me. Don't think that would be the problem, but let's do a no and pull this guy out. Type in neighbor of 10.255.1.1 next hop self, and do a do clear IP BGP star soft. Go back to router 1. Closing. So it's idle. It should form an adjacency. There it goes. And there we have it. So now we do show IP BGP. So now I've got the routes in via 5 as well. So I fixed that. But it doesn't make it, it's not changing anything. Because unless it's seeing it, that's the only frustrating part right now, is I'm not sure why it's acting up the way it is. I'm not sure what I'm doing wrong. So let's do BGP AS notation dot show IP BGP then. So it sees this 1414 coming in. This route right here, I'm not going to be able to affect, but this route right here, it should be a local pref of 101,000. So let's do a clear IP BGP star soft. Yeah, it's not affecting it. I don't know why. But what I'm going to do here is on router 5, instead of do this this route map, so do show run pipe section route dash map. What I'm going to do is I'm going to pull that access list out of there, that AS path ACL. I'm going to drop in the this guy right here. Where'd it go? This guy right here. I'm going to pull this one out. I'm going to type in this guy, and I'm going to type in match IP address in prefix list R10 loop, and I'm going to type in no and pull this match AS path, because then what will end up happening is I will be able to see it with just that route going out towards router 6, and then I'll be able to come here and type in IP prefix list R10 loopback. We're going to permit 10.255.10.10/32, and we're going to go to we're going to do a do clear IP BGP star soft. So that's only going to permit it for that. We're going to go to router 1, and there it goes. Now it's coming in correctly. Now we should be going towards 56. Now if I do a trace route to 10.255.10.10, we should go out router 56, which we do. That's what you want to see. That means it's working correctly. That's how you get specific, and if for whatever reason it just was not pulling in that information. Maybe it just was a bad syntax. Maybe I should have. Maybe it doesn't recognize it in the dot. Maybe I need to see it as whatever it is before it gets AS notation. Honestly, I don't know. So at least that's working now. So that's how local preference works. It's not a very difficult one to work with, but as you can see, if you have, I'm kind of being unique with the AS path information. Typically, I would use a prefix list and say I want to use a prefix list going this direction, and then you could reapply that wherever you need to, using a route map, and go from there. So I hope this has been informative for you, and I'd like to thank you for viewing.